In this video, you will learn how to graph quadratic functions in standard form. Let's look at example number 1. We have y equals negative x squared minus 4x minus 5. We'll first need to name our a, b, and c values for this function. So our a is negative 1, b is negative 4, and c is negative 5. We'll use those in the axis of symmetry formula and then find the vertex. So the axis of symmetry formula is negative b over 2a. So let's plug in our numbers. Negative 1 times negative 4 over 2 times negative 1, plugging in the a and b values from our function. So negative 1 times negative 4 is 4, and 2 times negative 1 is negative 2. When you simplify, you find the axis of symmetry to be negative 2. Let's use that value as you will use that value as the x value of the vertex. We now just need to solve for the y value. You'll use the original equation to solve for that y value. Plug in the x of negative 2. Use order of operations to solve for the y. So negative 2 squared is positive 4, doing exponents first, and then we'll multiply. Finally, add from left to right, and you should find the y value to be negative 1. So our vertex is at negative 2, negative 1. Looking back at our a value, we know our graph should open down because that value is negative. So when you think about a quadratic, when the graph is opening down, that would mean our vertex is the maximum point. Also think about the fact that your vertex is in the center of your parabola. So we're going to make a table of values, and we're going to put the vertex in the center of that table, leaving enough room for 5 ordered pairs, and the vertex will go in the center of that. Because just like the vertex is in the center of the parabola, putting that in the center of the table will help us get 2 to the left and 2 to the right. So pick 2 values less than and greater than your x value. From here, you could plug in this x value just as we did for the vertex and evaluate each y value. Or you can just use the graphing calculator. So with the graphing calculator, go to your y equals menu on the top row of buttons, press y equals, and type in the equation. So negative, make sure you use the negative key on the very bottom under the 3. Negative x squared, the x is under the mode key, minus 4x minus 5. Once you have that function into your calculator, you can press second, which is the blue key, table, so you'll look for the word table in blue, which is above the graph button, second table, and you can view the table of values. Notice my table starts at negative 7. You may need to scroll up and down to view the table of values that you need. So we'll scroll down a little to view from negative 4 to 0 the values that we need in our table. So notice in our y column, we should have negative 5, negative 2. We already solved for the vertex, negative 1, and then a negative 2 and a negative 5. If you ever notice that your vertex is not matching what you solved, you could either check that you correctly entered the equation into y equals, or go back and check your vertex work. So now we'll graph these on graph paper. So we have our x and y axes. We'll have our first point at -4, -5, so move left and then down. -3, -2, again left and down. -2, -1. -1, -2. And finally 0, 0 on the x-axis, and then -5 going down. So we see that U shape, our vertex here in the center. It is our maximum point. So we will connect those with a smooth curved line to draw our parabola. Let's look at example 2. Example 2, we have y equals 2x squared minus 6. Again, start by naming your a, b, and c values. Here we have a equals 2. B is actually 0, not -6. Remember, when you're naming a, b, and c, it's ax squared plus bx plus c for standard form. Because this is not an x term, we cannot call it our b value. That is actually -6 is our c value. Let's use those in the axis of symmetry formula. Axis symmetry formula is -b over 2a, so let's plug in our values. -1 times 0 over 2 times 2. -1 times 0 is 0, 2 times 2 is 4, so our axis of symmetry is 0. Using that, we'll put it as our x value of our vertex. We need to solve for our y value. So go back and use your original equation. So y equals 2 times 0 squared minus 6. Use order of operation to solve for y. So exponents first, we have 0 squared, which is 0. Then we'll multiply and finally subtract. So we get our y value of our vertex to be -6. Noticing your a value being a positive, this graph will open up. So if we imagine the graph opening up, this vertex at 0, -6 will be the lowest point of the graph. It's also in the center. So we'll make a table of values, xy ordered pair table of values, putting that vertex in the middle. You'll then pick two numbers less than and two numbers greater than to complete your table. You could take each of these x values, -2, and plug it in as you did to find the vertex. -1, and again, plug it in and work it out. But you could also use the graphing calculator. So let's go back. Clear out what you have in the y equals menu. Remember, to get to the y equals, that top row of buttons, press y equals. So here, y equals, and type in your equation. 2x squared, the x is under the mode key, squared is in that first column of buttons, minus 6. Your equation has to look exactly as it was given to you for the calculator to generate the table. So do second table, second is the blue key, and then you're looking for the blue words table. Scroll till you find the numbers that you need from -2 to 2. So we need to go down just a bit. There's -2. Our y value would be 2. And then -4. We're feeling pretty confident right now because our vertex came out to be exactly as we calculated it to be. -4, and then positive 2. So let's graph this on our graph paper. Our x and y axes. So for -2, 2, we'll go left and then up. So left 2 and then up 2. And then we have -1, -4. So left and then down 4. 0, -6. So 0 on the x-axis and then -6 on the y-axis. We have 1, -4. And notice we should have this mirroring image of the points. 2, positive 2. Again, that mirroring image of the points. Connect them to form that smooth curved line. That's a U shape. Notice our vertex is at 0, -6 as we said it would, and our axis symmetry is this x equals 0 line. It's difficult to see because of the y-axis, but we can go back and look at example number 1 and see again, our vertex is where we said it would be at -2, -1, and the axis of symmetry, that vertical line that cuts it symmetrical, is where we said it would be at x equals -2. Also with the graphing calculator, so going back looking at number 2, we had our equation in there, 2x squared minus 6. We've used the table of values to help us graph, but you could always hit the graph button to match your graph to see that they do match. Never try to mimic this graph to your graph paper because it's very difficult to get the exact points. So use the table to get the exact points and then just press the graph button to see that the pictures are the same.